Hi guys, welcome back to my channel Pirai Academy. In this series of data structure playlist, today we are going to see about logical implementation of circular linked list. Okay, my kind request is go and watch my singly linked list implementation first, so that you can understand this circular linked list and able to implement by your own. Okay, my request is don't go with the code implementation blindly. First implement the code implementation by yourself, understanding the concept. After understanding the concept, so that you can able to understand what are all the mistakes you are doing. Okay, afterwards go and watch my video. Okay, that's my kind request, and I will be giving you some basics of this circular linked list, and then by taking that basics and also the implementation of the singly linked list, your job is to just implement the circular linked list by your own first. Okay, then come back and watch this video. Okay, fine. So see here, in circular linked list, we can define it as the last node or the tail node. It's next going to be the head node or the first node. For example, if this is a some kind of singly linked list, for example, it is a singly linked list, right? In circular linked list, there will be slight one pointer. So here, this pointer will be pointing towards this. That's it. This is the only difference between the singly and the circular linked list in the basic implementation. Okay, and your node going to be same as a singly data and its next address. That's it. So this is going to be a node attributes also. So now by using these data, you can implement the circular linked list if you know the singly linked list, right? Go and try by yourself. Now, if you cannot understand or you cannot implement by your own or you made some mistake, just continue this video. Okay, fine. Now, let's take the ADTs of circular linked list. So what are all those ADTs of circular linked list? It is same as the singly and doubly linked list. Okay, so for example, I am taking this. So here I have three functionalities, right? So first one is insertion, second one is deletion, third one is traversing. Insertion we have three: insert at beginning, insert at ending, insert at some particular index. Meanwhile, delete is also having delete at start or beginning, delete at end, delete at some particular index. And also traversing means we are just going to traverse the entire linked list. That's it. Okay, so these are all the ADTs of circular linked list. Now by using these ADTs, let me implement the logic path. Okay, so that you can go and implement the coding path. So see here, first of all, initially I'll be having a head pointer and the tail pointer as null. Okay, so this is the first step. Why? Because as we know, initially my linked list is empty, and in our circular linked list we have head and a tail pointer. So both should be equal to null, so that I can understand my linked list is empty. Okay, fine. Now the first thing is insert at beginning. So when the insert at beginning is encountered, we want to do what? We want to create a new node. So let me create a new node. So this is a new node. Okay, so node have two attributes. One is data and another one is next address. So what is the data? Data is 5, and what is its next address? It is going to be null. Finish. Now what should I do? I should be pointing my head towards it, also tail towards it, which means hey, I have only one element, and that's the reason why I am making my head and tail pointing to the same element or node. Okay, now take for example, its address is going to be 200. Then what should I do is, at last I will be making its next value to 200. You may ask why we are making this as 200. Because the circular linked list have a property: tails next should be always equal to head. Okay, here the tail is the same node and head is also that particular same node. So that's the reason why this node itself having a self loop. That's it. Can you understand this? So this is the case of circular linked list. Okay, now insert at beginning of 12. So meanwhile I am creating a new node, as you know. So 12 and null. Let us take the node's address is going to be 1000. Now whether the linked list is empty? No, because head and tail pointing to some values. Okay, now what I am going to do is, this new node next going to be pointing towards this 200, which means I have a connection between them, which means the new nodes next is going to be pointing towards the head, Now I will be making my head to point towards the new node. Now I will be making my tails next going to be head, which means making this as 1000, which means I have a loop like this. Can I understand as of now? Okay, fine. Now what's the next step? Next thing is insert at ending. Now also I'll be creating a new node. Okay, and what's going to be its value? It's 7. Okay, 7, and its next value going to be null initially. And take for example, its address is 500. Okay, now it's a new node. Now it is going to be inserted at the end, which means what should I do? I'll be making my tail pointers next to be new node, which means I'll be making this 1000 into 500, which means I'll be having, instead of having a loop like this, a connection like this, now this connection is deleted and this connection will be implemented. Yes, now I'll be making my tail to move one step ahead to the new node. Okay, now I'll be making my tail pointer to pointing the next towards the head. So head's value is going to be 1000. So make this as 1000. Now how my link will be? It will be like this. Tail node next is going to be, yes. Okay, now what's the next thing? Next thing is insert at particular end is called 2. So when here it is like this, then what should I do? Let me put like this. Okay, now understand this. Insert at some particular end is 2. Okay, now I will be first going towards the first index, and from that first index I am going to insert some new node to its next index. For example, here let me represent. This is going to be 0th index, this is going to be first index, this is going to be second index. Okay, so I want to make the circular linked list like 12, 5, then comes 2, then comes 7. So this is how my circular linked list should be after inserting the index. Here I made a mistake. Here we want 2 parameters. So 2, 2, which means I want to insert 2 at the index 2. Can you understand this? So that's slight mistake. Rectify this. Okay, fine. Now this will be resulting in 12, 5, 2 and 7. 7 will be connected towards the 12th index. So 12 node. Okay, so this is how the linked list should be after I inserted 2 at the index 2, right? So how I am going to do this is, I want to first I want to traverse to the first index. Okay, always remember, if I want to insert or delete at the second index, then I want to go to the first index first. Okay, how I am going to do? I will be taking a temporary pointer called current, okay, at the head. Now I will be taking a count variable is equal to 0 initially. Now I will be just traversing one time. If I traverse one time, it comes here and count will be 1. Okay, whether I want to traverse again, no, because already you are at the index number 1. So count is equal to 1, which means you are at the index number 1. So don't do anything. Okay, stand there. Now what I am going to do is, I will be creating a new node. Since we have this first index, if I don't have the first index node, then it is impossible to create the second index. Okay, now I have a first index, that's why I am going to create a new node. So what is the new node? It will be, data will be 2 and its next address going to be null initially, and its address, for example, 700. Now what I am going to do is, I will make my new node next point to the current's next. What is current's next? Current's next is 500. So I will be making this as 500. Can you understand this? This as 500. Now this link will be not there. Instead, here comes a link like this. Okay, now I will be making my current next as new node, which means here comes the 700. So that's the reason why I just deleted this link. Now I have successfully inserted. Can you understand this? Now I successfully inserted. You may ask, what if the index is 3? What if index is 3? 3 means, for example, see here 12, 5 and 7. So these are the nodes as of now I have before inserting 2, right? If the index is 3, then it means insert at the ending, right? Insert at the ending. So why should I bother about inserting it? I just call the insert at ending function. That's it. Can I understand this? Okay, fine. Now let's get into the next thing. Next thing is insert at index 5. Take for example some value 10. Okay, some value 10. Now again I'll be making my current pointer here. So it looks clumsy, right? So let me erase it and redraw it. Just a minute. Now here comes delete at some particular index 2, which means I want to delete the second index. So this particular node should be deleted. Now let's see how we are going to do this. So it also similar to the insertion. Okay, for deleting the particular index at 2, then I want to stand at the first index so that I can delete it, right? So here I will be taking a temporary variable current. Now I want to traverse this how many times? Only one times, because see here, what is the value? It is 2. Okay, it is 2. So I'll be traversing only one time. So let me traverse here. Fine. Now I want to check whether it is equal to the tail. No. Whether its next is equal to the head. No. At this particular case, I am safe. I am safe because if its next is equal to the head, then that means the particular index is not existing. I'll be telling those edge cases also. Now as of now, listen this. Okay. Now I am standing here. Now what I'm going to do is I'll be making another pointer to point here as temp. Okay, the current's next going to be temp or delete. Just T. Okay, fine. Now I'll be making this 700 to point to this particular value. How? I'll be making my currents next, which means I'll be making the currents next as 500. So make this as 500, which means I'll be having a link between this, like this. Okay, now I'll be freely deleting the value D, the variable D. So which means this node is deleted. Can you understand this? So this is how we are going to delete a particular index. Now again if I doing delete at particular index called 2, for example, if I am doing this, then again what will be doing? I'll be standing at this particular point with my current. Now its next value is going to be tail. Its next value is going to be tail, which means I want to delete at end. Here itself I will be telling you, hey, you don't want to do anything, just to call the delete at end function. Okay, for example, if I am going to delete at index 3, now listen this carefully. It's going to be more important. First of all, my current will be here, then here, then here. So this is my last point, right? So if I want to delete the third index, then I want to stand at the second index. As this particular node is deleted, now this is going to be the second index, right? Now my current will be standing at this particular point. What is its next value? Its next value is going to be head, which means we don't even have some particular index called 3. Then I don't want to delete anything. I will be returning that. Can I understand this? So this is going to be the edge condition. Okay. So my core intention is I want you to know about this. Okay. Fine. Now let's continue with this. So here delete at end. So delete at end means we want to go to the tails front node. Okay. So initially now I'll be having a current value here. Okay. Now I want to traverse and check whether the current's next node is a tail. No. Then traverse. Now check whether current's next node is tail. Yes, it is a tail. Then what should I do? I will be simply making my connection towards the head and delete the tail and make the tail to the current. Listen this carefully. Make its connection to the head, which means make its connection to the head. So this particular linkage will be broken, and here comes a linkage like this. Okay, it's the first step. What's going to be the second step? Second step is delete the tail node. Delete the tail node. So this node is deleted. So this linkage will be deleted. Okay. What's the third step? Make the current as a tail. That's it. Can you understand this? So now my linked list is simply looking like what? Here comes 12, here comes 200, here comes 5, and here comes 1000, which means it is pointing here, and this is pointing towards here, and this is going to be my head, and this is going to be my tail. So this is how my circular linked list as of now looks like. Okay. Now what's the next thing? Delete at beginning. Okay. So delete at beginning means just make this head to move one step forward and delete this. That's it. And make the tail to point to the new head. Okay, that's the property of the singular linked list. Now, circular linked list. Now, what I'm going to do is I'll be making this as some temporary variable to delete. So D. Okay, and make my head to move to the head next. Head to move to the head next. Okay, now my head will be moving to here. Okay, now I'll be deleting the node D. Delete this. Now I'll be pointing my tail next to the head. What is the head address? It is 200. This address is 200, right? So 200. So as of now, here comes 5, 200. So it is the head and tail, and it has a self loop. Can I understand this? So this is how my new circular linked list will be. Again, I am doing what? Delete at end. So again, if it is deleted at end, what should we do? I will be just going from the head to the tail's front node. But here, how many nodes are present? Only one node. How I am telling that here only one node is present? Because tail and head both are pointing to the same node. When this case is arrived, then you want to delete the either head or tail and make head is equal to tail is equal to null. That's it. Can you understand this? So this is how you want to do when we have only one node. Okay. Now next thing is delete at beginning. When I am doing a delete at beginning, what should I do? I will be checking whether my head and tail is equal to null. Yes, then there is nothing to delete. So I will be printing a message called, hey, there is no elements to delete. The linked list is empty. Okay, so this is how we want to implement all the things, and let us compare the time complexity. So what is the time complexity? So we have insertion. So insertion we have three things. So beginning, ending, and index. So what is the beginning time complexity? It will be O of 1, and here it will be O of 1, and in index it may be in the worst case of O of n, because we want to insert at the last index. So in that case it will be O of n, because we don't know what is the linked list sizes. Okay, for example, we have 5 node. I want to place at the 4th node, then I want to go and traverse up to that. Okay, so that's the reason why it will be O of n. And in deletion also the same thing. So beginning, ending, and insert at some particular index. So here it is O of 1, here it is O of 1, but here it will be O of n. Sorry, here also O of n, right? Delete at ending, because we want to go up to the last sprint index. Okay, that's the reason why it will be O of n. Fine. Now, what is the time complexity for traversing? It also O of n. What is the space complexity? It will be O of n because of the user choice. We want to store n number of elements, right? Okay. So this is what the total time and space complexity of implementing the circular linked list. And now you can try the code by yourself. If you cannot get it, come and watch the next video. If you really like this video and subscribe to my channel. Don't skip any videos in this playlist, because all videos will be helpful once you are going for competitive programming. And if you have any doubts, then you can ask in the comment section. I'll be commenting a doubt, or I'll be giving you a separate video on it. Thank you.